because they didn't give me any examples to go through. So let's do a 1/3 plus 1/2. Now again, you can say, Mr. McGowan, these are fractions. I know, I got it. But actually, let me do, hold on. Let's do 3 examples. Okay, so let's say I had 1/3 plus 1/3. Okay, 1 plus 1/3 equals 2/3. Got it. Okay, that's going to be example 1. I'll get to those in just a second. I got a mindset here coming in here, guys, so play with me. Here I have 1/2 plus 1/3. Well, here you got to get common denominators, right? So the common denominator here is going to be 6. So what I'm going to do is I'll multiply a 3/3 and then a 2/2. Right? So therefore now I have a 1/6 plus a, sorry, not a 1/6, a 3/6. 3/6 plus a 2/6, which equals a 5/6. Okay? And then that's the third example, or second example. Now the third example, oops, I don't have room for that. Well, you know what? Let's just go with it on this. So that's fine. We'll just do these 2 examples. That's what the student will get. So I always like seeing math problems, or at least a little bit more context in what you need help with. So the reason why this could look like this, guys, is let's say I have, x squared plus 3x divided by, let's just say x plus 3. Plus, and let's just do a 2x squared minus 7 all over a x plus 3. Okay, well, guys, if they have the same denominator, it doesn't matter if it's 3 or x plus 3. Those are the same, right? So since those are the same, you just combine the numerator and leave the denominator the same. So I can combine the x squared with the 2x squared, right? Those are like terms. And there's really nothing else I can combine. So my final answer is a 3x squared plus 3x minus 7 all over a x plus 3. Done. Now in this example, I could say, well, let's just do it as a 1 over x plus 2 plus a 1 over x plus 3. Okay. Now, how do you combine these? Well, these do not have the same denominators, right? So we have to find a common denominator. Now, without getting into too much detail, a easy way to find a common denominator is just like I did over here, is just multiply by the other denominator. Again, this is a very simplified approach because that does not always work. But in this scenario, that is exactly what I'm going to want to do. Oh, geez. So in this case, I'm going to multiply by an x plus 3 all over a x plus 3. And then here I'll multiply by an x plus 2 all over a x plus 2. Okay, and again, make sure you multiply in the numerator and the denominator on both of those. So now I obtain a x plus 3 all over, and now we could simplify this, but I'll just leave this as, actually, let's simplify this. If you multiply this through, that'd give you a x squared plus 5x plus 6. And then this is going to be an x plus 2 over a x squared plus 5x plus 6. All right, so then what I want you guys to see is, hey, guess what? They have the same denominator. So now I can combine the numerators. So really, guys, adding and subtracting rational fractions is the same thing with fractions. The only difference is now we're dealing with polynomials than fractions, right? So when you're combining, you got to combine like terms. And the LCD of the denominator sometimes can be a little bit more confusing. But again, if you want to think about just like multiplying here by the other denominator to get a common denominator, that will work. And I think we're going to do another rational expression here coming up. So that's why I'll be fine sticking with the simpler solution here. So this becomes 2x plus 5 all over a x squared plus 5x plus 6. And there you go.